In this video, we're going to look at another method of graphing these quadratics, these parabolas. We spent the last few videos or so talking about what happens if it's in standard form, right? So for standard form, um, that's the one that looks like this. It's the equation y is equal to ax squared plus bx plus c. And we looked at what each piece did to the graph, right? The A value controlled whether it opened up or it opened down, also if it was wide or narrow. And then the B value was probably the most important part because it controlled where the vertex was, right, where that center point is, okay? I'm going to show you another format called vertex form. Now this one, it looks very confusing, but once you know the pieces, it's actually very nice and easy as far as graphing goes. It's probably even easier than standard form for as far as graphing purposes go. So here's what it looks like. Y is equal to A, so we see that part again, but then parentheses x minus h squared plus k. Now you'll see this one a lot when you're kind of working with specifically with graphing because it kind of tells you where the vertex is like right away just by looking at it. Okay, but there are still like three key components, right? So the first key component is still that a value. Okay, that's still going to control whether it goes up or down, and as well as how like wide or narrow it is. Okay. The other key things in here, probably a couple new letters that you may not have seen before, is the H and the K value. Okay. Now, what those are telling you is that it's actually telling you where the vertex is actually located. Okay. So for this one, you don't actually have to do any kind of calculation, right? So if you look back at the standard form, if you were when you're doing the vertex, what you had to do was you had to get that negative b over 2a, kind of figure out what that was, and then plug that in to get the other half, right? So it involves some calculations, okay? In vertex form, there's not any calculations at all, okay? The vertex is literally, you look at the H piece, so I'm gonna highlight this in red, okay? So the vertex is at H, comma, K, okay? But a couple things to make sure to point out, there's a couple things we need to be very, very careful of. So we know that the H value, that's controlling the left and the right of the vertex, the X component, that's why it's in the X position. But there's a catch. Notice I also highlighted that negative in there, right? It's negative H, but then when you write it in the vertex, it's now positive H. So make sure when you're doing these vertex questions, you always do the opposite of whatever H is. So if H is negative in that spot, then your vertex will be positive. If it's already positive in the equation, then it'll be negative in your vertex. Okay, the H value changes its sign. Okay, the K value, that controls the up and down parts, but there is no change. It's just wherever K is. If K is positive, then the vertex is positive. If K is negative, then the vertex is negative. Okay, so the one to watch out for is definitely that H value. Okay, I would put a star next to that. Make sure you guys make that little note. Okay. Now let me guys show you how easy vertex form is. So here's what a basic question would sound like. Okay, it would say graph, and it would give you the equation y is equal to x minus 2 squared plus 1. Okay, let me scroll down a little bit. I'll leave that up there. Okay, let's go and draw like a standard size graph, like 5 by 5. Remember, the nicer your graph, the easier it is to actually be accurate. So make sure if you're hand drawing it, spend some time, make sure it's nice. Okay, so we can already go ahead and jump to writing down what the vertex is going to be. Now, I did talk about that a value, right? There is an a value in here. It's that invisible 1 again. Okay, so we know that our graph is going to be facing up, and we know it's going to be kind of like the standard size, right? It's not necessarily wide or narrow. It's the normal, kind of matches the parent function, okay? So let's go ahead and write down our vertex. So our vertex right away we know that our h value is -2 and our k value is 1. So that means our vertex, when we write it out, we got to change that sign. So it was -2 here, so it's going to be +2 in the vertex. And then the k is +1, so it's going to be +1 in the vertex. So again, you only change that x or the h value. Okay, the k value does not change. And then once you know where that vertex is, then we're back to what we did with the standard form equation, right? Once you know where that middle term is, we can figure out the other ones pretty easily, right? We can make a very brief table, x, y. Okay, we know our vertex needs to go in the middle, so let's put the 2, 1 in the middle. Then we need two numbers above 2 and then two numbers below 2. That'll give us a decent graph. So if the middle is 2, then we can go 3 and 4. Then below we can go 1 and 0. Okay. Then we got to fill in that graph, plot the points, and then we're done. Okay, so there's no calculations involved in getting that vertex, which is really nice. Okay. Again, you get to choose, because remember we do know that whatever we get for 3 has to match whatever we get for 1, because it's symmetrical. And whatever we get for 4 has to match whatever we get for 0, again, because it's symmetrical. Okay, so you can plug in 3 and 4, or you can plug in 1 and 0, or any combination like that. Okay, I think plugging in 1 and 0 sounds a lot easier, so I'm going to go with that. So this is what you would need to show. If this was a quiz or a test, I'd be looking for this information. So plugging in 1, it would look like this. So there's no a value, so parentheses, plugging in 1 minus 2 squared plus 1. Okay. And again, you guys can use that Desmos calculator that I showed you guys. You can just Google Desmos scientific calculator, and it should be the first one that pops up. You could type it in exactly the way it looks with the parentheses, and it'll give you the answer right away. Or you can do it by hand, right? So 1 minus 2 inside the parentheses, that's -1. Then -1 squared, back to being +1. And then finally +1, so we get 2. Okay? But again, you have to at least show this on paper to get full credit, because you can use a calculator after that. Okay, plugging in 0. Again, make sure you are showing me that you are plugging that in. So 0 minus 2 squared plus 1. Again, make sure you guys are writing that down. So you can plug that in a calculator, or you can do it by hand. If you do it by hand, 0 minus 2 is -2. -2 squared is 4. And then 4 plus 1 is 5. Okay? And because it's symmetrical, we automatically know this one also has to be a 2, and this one also has to be a 5. And then we're pretty much done. Plot the points, and then draw our graph. That's it. So first one, 4, 5. Right 4, up 5. So 1, 2, 3, 4, up 5 here. 3, 2, right 3, up 2. Right there. Okay, the vertex, I'll do that one in purple. 2, 1, right 2, up 1. There's the vertex. And then we know the other ones have to be symmetrical and match, right? So they need to be level with the other one. So 1, 2 would be here. And then 0, 5 would be here. And we know what's our standard width, so it's not necessarily wide or narrow. So draw a U like so. Then you're done, okay? So again, the advantage of vertex form is it's showing you what the vertex is in the equation itself. No calculations involved, okay? I do want you guys to try one on your own. So let me scroll down, okay? And I want you to go ahead and try this one. So graph y is equal to -1/2 parentheses x plus 2 squared minus 2. Okay, we know some information right off the bat before I let you guys try it. Looking at that a value, remember, it's negative, so your parabola should be upside down. Okay, it should be opening downwards, and that's a half, so that means it should be wide. Okay, so it's wide upside down. Okay, all right, go ahead and pause the video at this point, try it out on your own. So we're gonna find the vertex, make a table, plot the points. Okay, so go ahead and pause the video and try it out on your own. Okay, hopefully you had a chance to try it on your own. If you're still kind of struggling with this, you can kind of follow along. So first up is the vertex, right? So the vertex, look at the h and the k values. So this says +2, so our vertex is going to be negative. It just changes, okay? And then the k value is -2, so our vertex is also -2. Remember, the only one you change is that h value, okay? So our vertex is located in the middle at -2, -2. Okay, two numbers above and two numbers below. So two numbers greater than -2 would be -1 and 0. Two numbers less than -2 would be -3 and -4. Okay, so that's the setup. Now we're kind of down to plugging in. Now this question, I would definitely use a calculator because you see that fraction in there. And I know fractions mess up a lot of people. And if it helps you when you're plugging in the fraction, you can think of 1/2 as the same thing as 0.5, if that helps you. Okay. So we got to plug some numbers in. I would go with the -1 and the 0. They're smaller numbers, probably easier to plug in. So this is what you would need to show on paper, right? So -1/2 or -0.5. If you're plugging in the calculator, it might be easier that way. And then we're plugging in -1. So -1 plus 2 minus 2. Oh, I forgot the squared part. Okay, and again, I would definitely probably use a calculator just to make sure you're correct. If you do it correctly, you should come out with -2.5. So we're getting a decimal here, which is fine. Okay, and we've got to do one more. So let's plug in 0. So -1/2, plugging in 0 plus 2 squared minus 2. Okay, again, you can plug that in the calculator, but make sure you guys are writing these things down, right? Show your work by writing these down. Okay. Again, if you do that correctly, you can use that Desmos calculator to double check. But if you plug in 0, out comes -4. Okay, and it has to be symmetrical. So this one has to be -2.5 as well. And this one has to be -4. All right, plot the points, and then we're done. Okay, so 0, -4 would be here. -1, -2.5. So that's left 1, down 2.5. So kind of about here. -2, -2. Left 2, down 2. So here's our vertex. Okay, and then -3, -2.5. Left 3, down 2.5, about there. And -4, -4. Left 4, down 4, right there. So you can see it's a very wide parabola. And then we're done.